Alright class, this is the last video for Unit 6, Trig Applications. Basically this is a review from geometry. So for each problem we're going to draw and label a picture, then write and solve the appropriate equation. All angles should be given to the nearest minute and lengths just to the nearest tenth for this worksheet. So, thing you need to remember, ka, toa. This tells you what each trig function is again, but we've been dealing with them, so you should know sine is opposite over the y over hypotenuse. Cosine is the, now that's only if it's a reference angle from the x, though. It depends on which angle you use. Cosine is adjacent over hypotenuse and tangent is opposite over adjacent. So a ladder is leaning against a house. So here's my house. Pretty standard house, has a chimney, has a window, has a door. Usually the window doesn't go right in the middle like that, but whatever. We have a ladder leaning against this, so we have grass. The ladder is here. So there's my ladder. There's my triangle. There's my ladder. You can assume that there is a right angle where the house meets the ground because it is perpendicular. Usually we make houses straight up and down. We know that the angle is 60 degrees from the ground, so it's there. The foot of the ladder, so the bottom of the ladder, is 7 feet from the bottom of the house. So this length is 7. We need to know how long the ladder is, x. Okay, so there's my triangle. I have an angle. I have the cosine or adjacent side to that, and then I have, okay, so I'm going to set up my trig function. If it's adjacent over hypotenuse, it's going to be a cosine function. Cosine of 60 degrees is equal to adjacent over x. Multiply both sides by x. X cosine 60 equals 7. Divide by cosine 60, you get x equals 7 over cosine of 60. And then you type that into your calculator. And you should get, because the cosine of 60, hopefully you guys remember for your unit circle, is 1/2. So 7 divided by 1/2 is just 14.0 feet. And that's it. Once you get here, this is what you're typing in. Okay, that's it. That's all we're doing today, pretty much. I am lagging, though, for some reason. Why is this not moving? There we go. So an airplane rises, when you hear the word vertically, you think, hopefully, the y, and horizontally the x. So I need to draw my plane. There's my airplane. That looks like a seagull. There's the pilot. Right. Anyway, there's my airplane. So here's where they took off. And they said that the airplane has gone up 1,000 feet vertically over a horizontal distance of 1 mile. Guys, you cannot put 1 mile down here. That won't make any sense. You need to convert. Hopefully you guys remember, though, that 1 mile is equal to 5280 feet. So that means that down here we have 5280, and I have an angle here. So this is going to be one where we're going to end up using tan inverse. But first we're going to actually set up our trig function. So we know that opposite over adjacent is tangent. So tangent of the angle that we want, angle of elevation is always at the horizontal, is equal to opposite over adjacent. So that means that x equals tan inverse of that, and you guys were doing those in your calculator before. Again, you type that in. Second tangent of 1,000 divided by 5280. And you get that, but we want DMS, so we do this. So it's 10 degrees, 43 minutes. So the angle of elevation is 10 degrees, 43 minutes, which makes sense because when you take off, or when you're, you don't want that big of an angle. So, well, this might not be takeoff. This could be in the middle of the flight. All right, a ranger is at the top of a 200-foot lookout tower located on a flat plane. So my flat plane will be here. Spots a fire at an angle of depression from the top of her tower. So here's the tower. There's the ranger with the ranger hat. sees the fire. I don't have brown, do I? So the fire, that's like the logs. And then we have flames. It's a good thing the ranger was looking out for this. We have some smoke. Yeah, it's pretty bad. Actually, let's throw a little blue flame in there because you guys know that that's really hot then. Okay, anyway, angle of depression is 3 degrees. What that means is it's the same thing as the elevation. If you look straight ahead and then down, this is 3 degrees, which means that this is still going to be 3 degrees down here at the base. We know that the tower is 200. We want to know what is the straight line distance from her to the fire. That is not the ground distance, that is the straight line distance from her to the fire. So we're going to say that. So I have an angle, an opposite, and a hypotenuse. So I'm going to use sine of my angle is equal to opposite over hypotenuse. Multiply both sides by x. You get x sine of 3 equals 200. And we get x equals 200 over the sine of 3. Since it's a very small angle, it should be pretty far. And sure enough, when you type that in, you get that the straight line distance from her to the fire is 3821.5 feet. When you type that in, you just do 200 divided by sine of 3. You do not do sine inverse. At a point on the ground 50 feet from the foot of a tree. I'm not going to draw a tree because it's right there. So here's the base of the tree. 50 feet, an angle of elevation to the top of the tree. Oh, I'll just do that, make it better there. An angle of elevation to the top of the tree is 53 degrees. Find the height of the tree. Okay, so this is a tangent setup because we want opposite, we have adjacent. So tangent of 53 equals opposite over adjacent. Okay. This is going to be one where we just have to multiply both sides by 50. So we get h is equal to 50 times the tangent of 53. Type that into your calculator. Again, you need to be in degree mode to do all this. And you get that the height is equal to 66.4 feet. Okay, so that is SOHCAHTOA trig again.